Hi there, good afternoon. Can you all hear me? Yeah. Hope you had a nice lunch. The topic for my talk is optimizing the full stack. And as Lena mentioned, I'm a solutions architect at Silverstripe. So this is a fast-paced talk about all the various things you can do to make your websites much faster. Most of the web is mediocre or slow, mediocre at best. So with all these techniques, we can make all the websites we build really fast. But before we get into various techniques to optimize, we have to consider why do we need to optimize? Or, much more importantly, how can we convince our boss that we need to optimize? Because we know we like to optimize. It's fun. You can do lots of fun, great stuff, and learn things, and we like fast websites, but our boss, ooh, optimizing. It costs money, doesn't it? No. I want features, not speed. Give me the features first. Those are more important for my business. So, to convince the boss, who has the money after all, you could show a graph like this. This is from Walmart. They did a study. Look at the red line, basically. At the bottom, the load speed of the web page. At the top, on the y-axis, how much profit they're losing as load speed increases. So basically, if a website loads in 0 to 1 seconds, they make maximum profit. In just 1 to 2 seconds, they've lost 50% of their profit. And Walmart's website loads in like 6 to 7 seconds. So that was an internal project to convince them to optimize their website, which I'm hoping they do. Also, a search engine optimization company did this study where they created 50 websites, identical websites with identical content. Look at the blue line, basically, and made them load in a range of 0.4 to 0.6 seconds, and left it on the internet for a couple of days, and compared to Google's search ranking position. And pretty much, the faster websites got the highest search rank. So, your boss hears this, he goes, hey, I can improve my search ranking by 50 positions in Google just by speeding up. Not quite, but if he believes it, all the better. But it does say that if you optimize your website, you do get a slightly higher search ranking position. And also, this happened a couple of months ago. I don't know if any of you caught it.
Facebook is already the way that millions of people get their news, but they're getting it in a fashion that Facebook considers really slow. It's taking an average of 8 seconds between the time you tap on a link inside the Facebook app and the time that the article fully loads on your phone. So they came up with instant articles. It's a way of downloading those articles to your phone at rapid speed, and in so doing, Facebook hopes that you'll start consuming more of those articles than ever before. That means that Facebook will get you to spend more time in the newsfeed, and maybe the publishers who are publishing their articles to Facebook will start seeing more ad revenue. It's a big idea, and it might actually change the future of media.
So average of 8 seconds for the average mobile website. We should be ashamed of ourselves. We can do better than that. That's why Facebook had to come up with their instant articles where stuff loads instantly. And they see a need. I see a need too. So here are 5 principles that you can use to improve the full stack, make everything go faster. Number 1, measure everything. I'll get into more detail of these, of course. Number 2, ignore your job title. And now you're scratching your head. What? And number 3, push to the left. Now everyone's like, this guy's gone mad up at stage there. Push to the left, that means nothing. And number 4, deliver fast content. And now you're nodding your head again. And number 5, cheat. And now you're shaking your head again. So let's start with principle number 1. Measure everything. So to identify the most bang for your buck, you could spend forever optimizing the tiniest millisecond improvements out of your website. But to get the most bang for your buck, you need to measure what's slow and focus on the stuff that's the most slow first. And if that thing that is most slow happens to be outside of your area of expertise to fix, ask for help. One way to measure, because you're optimizing the full stack, there's no single tool, at least I haven't found a single tool, that is able to tell you where your performance bottleneck is from an end-to-end point of view. So you need to use multiple tools to measure different parts of your application. One thing you can do is use something like XHProf in PHP, a Facebook tool that basically looks through all your code, runs it, and identifies what the slowest parts are. And you can use a nice visualization library to tell you, like, load class, in this example, they found, is the slowest, and then the yellow bits are the critical path that's also slow. And the white stuff doesn't really matter. So if you haven't used XHBroth, give it a go, install it, it's great. And for JavaScript, if you want to measure JavaScript, you can use JSPerf, which is a JavaScript playground where you can put together an A/B test, basically, of two solutions and measure which performs faster. JSPerf will run it like 1,000 times in the browser and compare speeds. And Chrome developer tools are really good. You can do CPU profiling in your web browser to measure stuff. So those three tools I use on a day-to-day basis to optimize, to figure out what's slow. Additionally, you can modify your web server configuration, Apache configuration. You can add that bit of punctuation into your Apache configuration file, and the %d at the end adds, which isn't in the default configuration, adds the number of microseconds that your request takes to load to every request. So every request that comes into your web server records how long it took to serve that request. And then if you do this bit of awk magic, you get a real-time feed of every request that takes longer than, say, half a second, 500,000 microseconds. Similarly, in your database, assuming you're using MySQL, you can turn on the slow request logs. So every request that's slower than a certain amount of time gets automatically logged into a log file, and you can look through that log file and so see, oh, these are the slow requests, these are the slow queries, these are the things I need to optimize. Additionally, there's even more analysis you can do. Something like why slow, or as mentioned this morning, you can also use the Chrome, what's it called? Google Page Speed Insights. So why slow or Google Page Speed gives you a report of what's wrong with your website, basically. I ran this on Silverstripe's website, silverstripe.org. I work for Silverstripe, of course. And we're not using a content delivery network. Oh, shame on us. We get an F. Coming soon, by the way. But for now, it's a good summary of what's wrong with your website, what you can fix to get some performance improvements. Then, one more, you can load test. Any good website should be load tested. Siege and Apache Bench are two tools that you can use that are really good for hammering your website, simulating a horde of angry users visiting your website and hitting the refresh button very fast. So you get a report out, you can analyze, do it before you optimize and after, and that way you have a good comparison to see how well your optimization did and how much faster your website is. So moving on. Next principle, ignore your job title. So who here considers themselves a back-end developer, mainly? Anyone? Yeah, a lot of people. Who's a designer? No designers. Who's a business owner? Who owns a business that has a website? One person. Who's a content author? Yeah, they call it. Yeah. So you do kind of have to play these unfamiliar, strange-sounding job titles, sometimes as a back-end developer, to be able to fully optimize the full stack. So, for example, minimalist content and design is a great way to optimize your website. You're not the content author, you're not the designer, and still, you can have influence on those people to optimize the website far more than anything you can do in your back-end code. For example, let's compare this website, familiar? People have seen it before, right? To this website. Dick Smith. Yeah. Which is more minimal? And I loaded them up in Chrome on my work internet connection, which is pretty fast. And Google loaded in 1.3 seconds. Dick Smith loaded in 12 seconds. Ooh. I've totally lost half your audience by then. How did they make any money? Anyone here work for Dick Smith? I'm insulting you. Build this website? No. OK. So minimalist content and design. Great way of minimizing your page load speed. If you do nothing else, you can do that. Also, You can scale horizontally. Using something like Amazon Web Services, you can, if you have a database that's running slow, for example, there's a neat pop-up menu where you can create a read replica, which you can spawn an instance of your database that you can hook up for reads. So you can have one database that's only for writing, assuming you get more reads from your database than writes. One database handles all the writes, propagates out all the writes to, say, 10 read replicas, and a whole bunch of web servers can read from those read replicas, and that's an easy way of scaling out your database without having to do any complicated programming other than pointing reads to one IP address and pointing writes to another. And similarly with application servers, if you run into issues where you're simply getting too much traffic for one server to handle, create more of them, scale them out. Auto-scaling is your friend in Amazon Web Services. Also, who here, yeah, this is a good question. Who here has, in your workplace, budget approval to spend $1,000? Oh, yeah. Good man. Well, not many, it seems, except our hero there. So, one principle is spend money, not time. For most people who are working professionally, you can add up what your salary is and how much that salary, how much time you'd have to spend to make $1,000 or to cost $1,000. So for most people, it's like a couple of days to a week, depending on how much you make. Assuming you want to write a really nice graphing, have some really nice graphing in your website, you could spend 3 months coding it yourself, or you could buy high charts for $1,000. High charts will give you a much nicer experience and be cheaper in the long run. But most developers, I find, because high charts cost money and we don't have approval to spend money, will instead choose the 3 months development path and end up costing the company so much money and making the project late and so many things. But don't be afraid to spend money to save time. All right, that's enough about ignoring your job title. What more can we do? Principle of push to the left. Not suggesting you do this. Instead, I'm suggesting, let's take this typical 3-tier application architecture, 3-tier of database, application server, and client. So what's the fastest database in the world? Anyone? No database. You got it. If you push to the left, you cache your database queries. The fastest database query is a query you don't have to make. So if you push content from the database to the application server, to the left, you don't need to get that content from the database. And if it's frequently accessed content, most content is accessed over and over again, the same content being read multiple times, it's going to serve much faster from your application server and not use so much space on your application server that you need to go back to the database. So push your content to the left, and you get great performance. So let's expand from a 3-tier architecture to a 4-tier architecture. I think there's a talk coming up about Nginx. So you add a load balancer or reverse proxy in another tier. And Nginx is a great choice for that. So you add Nginx as a reverse proxy or load balancer in front of your application servers. It can distribute load between multiple application servers, and it can directly serve static content, images, PDFs, that kind of thing, directly to the client without even touching the application servers. You're pushing your content even further to the left, such that your application servers can be optimized for what they're supposed to do, for serving dynamic content. That's what they're good at. That's what they're fast at. And your reverse proxy load balancer can do stuff, can do what it is good at, serving static files. And taking this even further, we can add a 5th tier, a content delivery network in there. So what's a content delivery network good for? Well, this video explains it.
Prepare to attack. Prepare to attack on the count of 3. 1, 2, 3. What happened? Where are they? I don't know, sir. They must have hyperjets on that thing. And what do we got on this thing? A Cuisinart? No, sir. We'll find them, catch them. Yes, sir. Prepare ship for light speed. No, light speed is too slow. Light speed too slow? Yes, we're gonna have to go right to ludicrous speed.
Yes, a CDN is good because light speed is too slow. To send a ping, to send a request through the optical fiber network that powers the world's internet from Wellington to, say, Dublin, takes half a second to go there and back. That's far too slow for most websites. Half a second, you've lost half your audience. So you use a CDN to distribute your content all over the world such that you can, no matter where your user is accessing that website, it's close to them, and the speed of light is not holding you back. And by the way, these 4 content delivery networks are ones with endpoints in Auckland. So those are the ones I'd use if you're writing a website with a primarily New Zealand audience, because those are close. Other CDNs don't think New Zealand is important enough to put some servers there. But those 4 do, so those are the 4 I would use. We at Silverstripe use both Encapsula and Cloudflare for our websites. And finally, taking this principle of pushing to the left to its ultimate. Let the browser do some work. Push way to the left, right into the browser. We did a project that had close to 1 million people visiting the website every week. And the client insisted that every page of that website had a logged in, had a little status thing at the top right corner that says, "Hello, Sam. Here's your shopping cart. Here's your..." And normally, doing a kind of personalized content with the user's name, you have to get it from the session, generate it dynamically in a dynamic request. 1 million dynamic requests a week would totally have killed our servers. So what did we do? We pushed to the far left and had stored the user's name in local storage on the user's machine, and had JavaScript rewrite the web page to add their name into a statically loaded page that came from the CDN. So the content delivery network would serve a static page, and JavaScript would just add their name in, saying, "Hello, Sam." Totally dynamic request, except it wasn't. We took advantage of this principle and managed to withstand the 1 million people visiting the website. All right, further on, another principle. Deliver fast content. This is the bread and butter stuff that I'm sure you all know and love. One principle within that category is to pre-compute. Here's some code I wrote a while back. We have a situation where this is in Silverstripe, we have a convenience method that you can call on after write. So after a database write, you can run some code. It's a hook you hook into. This was a people database, so we had a JavaScript front end that displayed people on a map. And instead of dynamically generating that list of people, and when the user pulled up that website, anytime the content author added, say, another person or changed the location of an existing person, we pre-generated all the data and created it as a JSON file and saved it onto the web server's file system. So it was a static request for a static file that our content delivery network could cache and distribute all over the world, and was really fast for everyone to load. Otherwise, it would have to come back to the application server. The application server would have to query the database for all the people, generate the JSON on the fly, return it. It would take ages. This, so much faster. Similarly, you can denormalize your database tables to eliminate joins in the database. Another technique that, because joins are slow, denormalizing database tables makes them faster. And you can statically cache your HTML files. Rather than generating the HTML in PHP, you generate them when they change, save them to the file system, and serve the HTML files directly. Another thing that you can do, everyone should be doing this already, is minify and combine. Most frameworks have some kind of method to do this for you. In Silverstripe, you can do requirements combined, specify a file name, and specify a whole bunch of files that you want to minify, eliminate all the comments and white space, and combine into one file. One file loads a lot quicker than a whole bunch of files. So do all that, and you get fewer HTTP requests, and a faster loading website. Another thing that you can do, compress your content. Most people do this already, but if you're not, it's an easy win. Check your website using that tool up there to check if you're compressing content. Basically, any modern web browser can accept gzip compressed content, and compressing content, sending it over the wire, uncompressing content, is so much faster than sending uncompressed content, which just wastes bandwidth unnecessarily. And that bit of Apache configuration allows you to easily compress your content. Just add that to your Apache config, and you get compressed content for free, basically. It takes you all of 5 minutes to implement. Furthermore, we can inline content. This is a pretty advanced optimization. If you pull up Chrome and look at the developer tools, the network tab, you get a graph like this when you load your website. And the various colors mean this. Gray, I can't really see it on the projector, but gray means stalled, meaning doing nothing. Then negotiating proxy servers, looking up the DNS, establishing the connection, doing an SSL handshake, sending the request, saying, give me the data, waiting for the server to respond, and downloading the data. So, in the example of Victoria Uni's website, you get the initial HTML file, which references a whole bunch of CSS, jQuery, and so on. And so for every one of these, it first has to wait a while doing nothing, then set up a new connection, then send a request saying, give me the content, then wait for the server to respond with the content, and then finally download the content. You can save all of this incidental stuff before the blue stuff that you actually want by taking jQuery and inlining it directly into the HTML document. For anything that is critical for the website, that you can't display the page without, images, you still see the page while the image loads in. That you shouldn't inline into your page. But anything that's critical for your page, such as the CSS, you can put right into the page HTML and load it quicker. If you look at the load times here for the style sheet, it's 38 milliseconds. You're not going to get much by doing this. But if you've done everything else, this is an advanced optimization that you can do to get yourself a few extra milliseconds. Also, to deliver fast content, you need to know your framework. In jQuery, for example, find is faster than children. So finding all child elements of a selector is faster than finding only the direct descendants of that selector. And most people who I tell this are like, huh? Really? Why? It doesn't make sense. The reason is that find is a native browser API thing that jQuery can call right in the browser. It's implemented in C. It's really fast. Whereas children first needs to do a find, then iterates through the found items to filter out everything but the direct descendants. So it's much slower than a find. In other frameworks, Angular, for example, popular. Say you have a website with a whole bunch of content, say a multi-stage form where the user sees a whole bunch of a long form and clicks through, say, 10 pages. You can use ngIf to hide the 9 pages that the user is not currently seeing, or you can use ngShow or ngHide to hide them. ngIf removes those things out of the DOM completely. They're not in the browser, which means data updates run a lot faster. Everything, the browser responds quicker because there's less content, less memory being used in the browser. ngShow just hides them, makes them display none in the browser, where they still exist in the DOM and use up memory, get updated in the background when something changes, slower. So knowing in Angular that ngIf is, in most cases, far faster than ngShow can give you a lot of faster content. And finally, in Silverstripe, generating a menu is really slow because you're iterating through a lot of pages, pulling them out of the database. But you can do partial caching in Silverstripe by caching that. So if the site tree, if the last edited database column in the tree of pages in the site hasn't changed, basically, if no one's edited a page on the site, then you can fetch all of that HTML from cache rather than generating it dynamically, thereby getting it much faster. One little query for one database field is much faster than calling that expensive menu. So partial caching, great way, if you know your framework, to speed up your content. And another principle, the final one, cheat. So cheating is all about knowing that the illusion of speed is far more important than actual speed. Cheating your way into creating a really fast website is both easier and better for the user than actually doing the hard work, hard yards, optimizing everything. So remember this?
If you don't have somebody in 10 seconds, they're out. Probably actually less than that.
That's why we built instant articles, a new way for publishers to create fast, interactive articles on Facebook. So when you tap on the article, it loads instantly.
Yep, it loads instantly. Next door, the guy from Facebook is probably explaining how they did this. I'd imagine it's something really simple, such as when Facebook just loads the stuff in the background. They can display an article instantly because they've already loaded it while using up all your bandwidth in the process. by the second you pull up Facebook, download all these instant articles onto your phone, onto your device, and then display them when you tap on them. And similarly in Pinterest or any kind of Twitter, any kind of app, you have the infinite scrolling thing, where you see the first page of pins or tweets, and at the bottom there's a spinner thing that if you scroll really fast, you can see it, load in more content. But if you're reading and scrolling slowly, it loads in content fast, such that it seems like it's an infinite web page, that it keeps going and going forever. And in both cases, it's loaded the content in the background. In one case, in the case of Pinterest or Twitter, you've loaded only the initial content that the user sees initially and load the stuff in the background as the user gets to it. Similarly, for like a long form, you only need to, if the user only sees the first page of the form, you can load the additional pages of the form in the background. And for something like Facebook Instant Articles, you can load the stuff before the user even sees it. Say you have a website where you know 80% of users click on a certain link, load the content of that link before the user clicks on it. And in a single-page app, you can do that no problem, and you get instant response. Facebook, the user is like, yay, this website, faster than Facebook. Pretty good. Another way you can cheat is queue. I love queues. Instead of, say you have a complex form submission that does a whole bunch of processing once the user submits that form. Say like a payment confirmation that checks their credit card and does all kinds of complicated shipping logic. Instead of doing all that when the user submits the form, waits for like 20 seconds while all the logic happens, comes back, transaction denied, and they go, oh, okay. Instead of that, you can accept the request, respond instantly, saying, yep, thanks for your request, processing. Go away, have a cup of coffee. They can tell the user. Enter that request into a queue. There are some servers in the background that do nothing but process the queue, do whatever complicated logic that you have. Once they've finished, they can put it into a response queue, and the web server can, say, send a push notification to the browser saying, yep, done, payment denied, try again, or payment success. Payment is not perhaps the best example because you kind of want to know if your payment is denied or accepted right from the start. But for video processing, for example, transcoding a video, definitely you put it into a queue, you do the processing, and hours later, you tell the user, you send the user an email saying, okay, your video is ready. You don't need to do all that stuff directly. Queues are your friend because you can respond instantly, give instant feedback to the user while doing a long-running request in the background. Also, run less PHP. We all have written PHP, probably, and we like to use big, complicated frameworks that make writing PHP a lot of fun and do away with a lot of the horribleness of PHP. But in some cases, running less code is faster. In a lot of cases, actually, running less code is faster. It's also faster to develop if you're writing less code. In one project we worked on, the client insisted that we record every user that visits a web page in the database. So increment a counter in the database for every time someone visits a particular page. So using the Silverstripe CMS, every time someone hits the page, you'd have to go into the database, spin up all of Silverstripe, which takes like 300 milliseconds, and use the object relational mapper to load up the page object, increment the counter, use the object relational mapper to save that page object back into the database. So it would have taken like half a second. Instead, what we did was write a simple 5-line PHP script that does connect database, increment, close connection. Much, much faster. Maybe not as easier to write, and satisfy the client's requirement. So sometimes your massive friendly framework is just too much, and you need to write as little PHP as you can, easy to test, and gets things done really fast. And the final way that you can cheat is to generalize the optimization. Use a platform host, such as VIP WordPress.com hosting, a killer Drupal cloud, or Silverstripe platform, where in Silverstripe's platform's case, for example, we've done all the hard work of adding most of these kind of optimizations into the platform directly, so you can take advantage of them on project after project without having to redo the optimization every time that you create a new project. So if you've generalized optimization, you have some starter template that you're always using, you're using some kind of platform hosting provider, you're doing something that means that when you make an optimization, all future projects that you work on take advantage of that optimization. That allows you to cheat because you don't have to do the optimization every time. You get it for free. So in summary, here's a cheat sheet that you can print out when you download these slides and hang on your wall and go look at your project, go, yeah, done that one, done that one, done that one. Ooh, CDN, no, need to look at that one. Circle that. And generally, optimize your full stack and get your project running really fast. Thank you very much. Email me if you want about anything, or check out Silverstripe.